Hello, I'm Ho Jung-sung, RA of the TM Lab. I'm going to give a presentation on English paper. The topic for today's presentation is development of a maturity model for technology intelligence. These are the key information and frequently used keywords related to this paper. Now, I'll provide a brief explanation of the main content. Technology intelligence becomes increasingly significant to respond to volatile business environments. Advancement of technology intelligence follows a logical maturation path. Maturity model concept helps measuring technology intelligence capabilities. Technology intelligence maturity model supports evaluating and planning a firm's technology intelligence process. Let us first take a look at the contents of the presentation. Introduction, background, research framework, results, lessons and discussions, and conclusions. The first chapter is on introduction. This paper highlights the importance of technology intelligence (TI) in responding to volatile business environments and the need for swift adaptation to technological changes. Existing approaches in measuring TI, such as case studies, data-driven methods, and toolkits, have been explored, but a lack of measurement methods for TI persists. Maturity models provide a framework for measuring organizational capabilities, offering practical implications and benchmarking opportunities. The research aims to develop the technology intelligence maturity model TIMM by reviewing relevant studies and conducting interviews with TI managers. The TIMM framework consists of components that capture the maturity of TI within organizations. Maturity determinants and measurement criteria are defined and incorporated into the TIMM model. The results and insights derived from the application of TIMM are presented, showcasing its effectiveness in measuring TI. Discussions focus on the practical implications of TIMM, its limitations and challenges in measuring TI. The paper concludes by highlighting future research opportunities and areas for improvement in TIMM. Next chapter is on background of technology intelligence. TI refers to the systematic process of capturing, analyzing, and utilizing information about technological trends, opportunities, and threats. It involves proactive efforts to identify emerging technologies, understand their implications, and make informed decisions to enhance an organization's competitive advantage. TI encompasses various activities such as monitoring technological developments, assessing their potential impact, and adapting strategies accordingly. By leveraging TI, organizations can study ahead of technological changes, drive innovation, and make informed decisions in dynamic business environments. There are three main research streams in TI. First, TI concepts, processes, and industrial cases. Second, data-driven approaches to capture technological changes. Third, development of toolkits for facilitating TI activities. Measurement and evaluation of technology intelligence are here. Gap in measuring TI capabilities and evaluating the quality of TI activities. Importance of assessing TI capabilities to enhance organizational competencies. Lack of academic and industry studies in this area. Finally, there is historical evolution of technology intelligence. Evolution of the term TI and its adoption in research. Emergence of TI as a subset of competitive and business intelligence. Academic focus on establishing a foundation for TI rather than exploring its implementation and evaluation. Maturity models are based on the concept of maturation, representing the sequential development of organizational capabilities from a lower level to a higher level of maturity. Two theoretical viewpoints exist for maturity models: the evolutionary viewpoint and the evolutionist viewpoint. The evolutionary viewpoint, derived from neuron stage theory, emphasized the step-by-step development process of organizational capabilities. The evolutionist viewpoint, derived from Crosby's maturity grid, focuses on the desired endpoint and maturity scale to explain the development course towards the final endpoint of maturity. In the context of this study, a maturity model is defined as a model that reflects the stage-by-stage development of organizational capabilities along with an anticipated and logical maturation path. Evolutionist models, which clearly design the desired endpoint and maturity scale, are commonly adopted in academia and industries. Several evolutionist models have been proposed for software development and other domains, including Industry 4.0, e-government, data analytics, blockchain, energy management, information management, and risk management. However, despite extensive research on maturity models for business intelligence, no maturity model specifically for technology intelligence has been suggested, indicating a significant need for an TI-focused maturity model. Maturity model typically consists of four components: maturity level, capability level, process area, and practice. Maturity level quantifies the overall competence of an organization's abilities, while capability level represents the quality of individual process areas. Process areas refer to subcomponents or subfunctions of an organization that contribute to achieving organizational goals. Practice, which are the basic units of organizational activities, form the process areas. The structural design of a maturity model can be illustrated using a focal formed value creation process as an example. The maturity model provides a framework for assessing and improving organizational capabilities in a systematic and structured manner, facilitating the maturation for technology intelligence and enhancing organizational competencies. I will introduce research framework. This research adopts an exploratory approach which is progressed with multiple case studies due to the absence of an extant study that measures a firm's TI capabilities and connects the concepts of TI and MM. Hence, we first review previous TI studies to develop a TI-MM architecture as groundwork and then conduct 8 interviews to concretize and confirm our proposal. Adopting an exploratory approach, firms involved in this study were selected from participants of the STIM consortium if they satisfied the following criteria. First, a firm must conduct at least one work task related to TI. Second, a firm must have a great interest in the TI process or a desire to enhance TI capabilities. Third, a firm can guarantee an interviewee responsible for managing the firm's overall TI process or has a detailed understanding of company-wide TI laws from their position as a TI worker for more than 5 years at the firm. Among 25 firms engaged in the STIM consortium, 8 firms, 32% were investigated in this study. The research process of this study consists of 3 steps, as depicted in Figure 2. In the first step, previous study related to TI and the innovation and management domain are reviewed to design the overall structure of the technology intelligence maturity model. The focus is on outlining process areas, capability levels, and maturity levels of TIMM. Detailed practice for the TIMM architecture are not determined at this stage, but narrative descriptions are prepared to identify practical TI activities from interviewees. The second step involves conducting semi-structured interviews based on the TIMM architecture derived from the first step. The interviews primarily address 2 lines of inquiry: the TI activities conducted by the company for each process area and how the maturity and capability levels for the firm's TI activities are determined based on the TIMM architecture. Through these interviews, detailed practice are collected and feedback, opinions, and criticisms regarding the proposed TIMM are obtained. Finally, after the interviews, the information gathered from the firm cases is summarized, organized, and shared with participants of the Strategic Technology and Innovation Management Consortium, including interviewees and other practitioners, scholars, through a STIM workshop. The purpose of the workshop is to share academic outcomes, discuss research findings, and provide practical application to industrial members and scholars involved in the STIM research project. The workshop consists of 3 sessions: an oral session presenting an overview of the research project, a group discussion session, and a poster session offering detailed information. The workshops were conducted 3 times in August, October, and November in 2018. After the workshop materials and a final version report were delivered to industrial members in December 2018, concluding the study and capturing academic ideas for future discussion. The first research stream, focusing on TI concepts and industrial cases, was reviewed to develop the architecture for the TIMM as the initial step. The task involved in constructing the TIMM architecture included decomposing TI activities into process areas, defining capability and maturity levels, and aligning TI process areas with the corresponding capability levels. This step aims to gather academic evidence from various domains and organize it into a cohesive architecture. Following the development of the TIMM architecture, TI practice were collected through interviews to concretize and validate the model, incorporating feedback and criticisms from industry perspectives. Throughout the research process, progress and findings were shared with participants of the Strategic Technology and Innovation Management Consortium through network meetings and a final workshop. This provides an opportunity for peer review-like validation of TIMM. Additionally, a summary of the TIMM application results and a comparative analysis were conducted to ensure the logical integrity of the model. 8 firms were interviewed as part of this research, and their key information is summarized in Table 2. This is the result of paper. The proposed TIMM consists of 3 components: maturity level, process areas, and capability level. Previous studies by Rich Tantarer, ISO IEC 33001, Kerr et al. And Crossan et al. Are used to develop these components. Recent tellers, 3 generations of TI processes are adjusted and merged with ISO IEC 33001 to establish maturity levels for TIMM. Kerr et al.'s conceptual model is adopted to design the process areas with some modifications. The capability levels for measuring process areas are based on Crossan et al.'s 4I model adapted to the TI context. An appraiser matrix is also developed to rank maturity levels, capability levels, and process areas. It provides a qualitative benchmark for assessing a firm's TI maturity level based on the achievement of capability levels in different process areas. Maturity levels for TIMM are established with some conceptual borrowing and merging, as shown in Figure 4. Each maturity level for the TIMM design is described in Table 3. Kerr et al. Developed a conceptual model explaining TI operations as illustrated in Figure 5. Explanations on process areas for TI are described in Table 4. Relevant innovation studies are reviewed to reorganize the 4I model under the TI context as described in Table 5. To rank maturity levels, capability levels, and process areas, we also developed an appraiser matrix for TIMM as illustrated in Figure 6. In this step, specific practices for each TI process area were determined based on interviews with 8 practitioners responsible for TI activities. The interviews were conducted using a semi-structured approach, considering the diverse needs and activities of TI in different business contexts. Open-ended questions were prepared in advance to explore the firm's business characteristics, technological domain, market competition, and TI operating activities. Through these interviews, actual practice aligned with TI process areas and capability levels were identified. The practice followed a staged growth logic corresponding to the achievement of capability and maturity levels. At the intuitive capability level, TI activities tend to be conducted independently and ad hoc without strong alignment with the company-wide strategy or other business functions. As the capability level progresses to the interpreted level, TI practices become more organized with defined roles and responsibilities within a TI team. The plan, do, check, act procedure is formally operated and relevant TI materials are discussed and shared within the team. At the integrated capability level, TI activities are systemized to communicate with other functions within the firm. TI contributions play a significant role in shaping comprehensive innovation and business strategies. Finally, at the institutionalized capability level, practice related to the evaluation and assessment of TI operations are established, allowing for continuous improvement based on evaluation results. An organizational approach is adopted to facilitate constructive criticism and enhance TI capabilities systematically. While personal opinions and feedback can influence TI work at any level, the institutionalized capability level represents a formal and organizational approach that fosters continuous improvement in TI activities. Based on interviews and TI practice, the capability levels of 8 firms across TI process areas were assessed in Figure 7. 2 firms with high technological volatility showed higher TI capabilities. In contrast, 2 firms with specific business strategies had lower TI capabilities. Technological uncertainty and business strategy influence the required level of TI capability. The following lessons and discussions were observed in this section. First, achieving a high level of TI maturity is not always necessary, but higher TI capability can result in more refined and elaborate TI message. It is important to match a firm's capability with its needs. Second, open innovation is effective and necessary regardless of a firm's TI maturity level. Collaboration with external organizations can be beneficial for both highly mature firms and those with lower maturity levels. Third, the TI process can be placed before or after developing a technology roadmap, depending on the firm's goals and needs. Fourth, management's support functions such as organizational training and culture management can significantly impact a firm's TI capabilities. However, these functions are not included in the TIMM architecture. Fifth, while various models for business intelligence exist, models for TI are scarce. The scope of business intelligence is broader, but specific intelligence concepts are becoming more significant in complex business environments. Finally, there are practical barriers to adopting TIMM, including limited generalization due to the study's limitations and different working environments of firms. In this study, we propose TIMM as a tool for measuring organizational TI capabilities. The TIMM architecture provides insights into a firm's TI maturity levels, capability levels, and practice, allowing users to assess their TI capabilities and identify areas for improvement. This research contributes academically by addressing the research gap in measuring TI, providing a practical understanding of TI in work practice, and serving as a foundation for future studies on measuring TI capabilities. It also offers practical contributions by helping firms assess their current TI status and reorganize their TI processes to enhance sensing capabilities. However, there are limitations, including the non-probability sampling of interview firms and the need to further explore the strategic drivers behind TI practices in future research. Thank you.